All right, so we had a upgrade to our heat pump water heater setup. I took the water heater up off the floor and installed it on this shelf. So I bolted this shelf to the wall and set the thing on top of it, reconfigured the piping so that it would come out at an angle. Previously these lines just came straight out of here, directly out. We added elbows to make them angle off so they wouldn't hit the side of the tank, because there isn't a whole lot of room back here. So I have to be able to clear this pipe and then also clear the tank. So I reconfigured it so that the water going into the heat pump actually is drawn from the cold water inlet of the tank. So this line here brings the cold water into the water heater tank. Okay, that's cold water coming in. Normally it would just go straight down, but instead we are tapping it off and sending it to the heat pump. So if I'm in the shower or we're using water at the time, cold water will actually go to the heat pump instead of it sucking the hot water from the tank. Now if it's generating hot water and no water is being drawn from the tank, it just sucks the water from the dip tube up into the heat pump. And the water goes into the heat exchanger on the heat pump. It gets heated up and it gets pushed back into the tank through the bottom drain valve. So this is actually the heated water going back into the tank. Now this setup was originally configured where I was putting the heated water back in through the pressure relief valve port. And that was a problem because the pump was taking the water out of the bottom of the tank, heating it slightly, putting it into the pressure relief valve port, which is at the top of the tank. What you were doing then is you were taking water that was cold at the bottom of the tank. You might have been adding 5 degrees to it, and then putting that water into the top of the tank, which has hot water in it. And it was diluting the temperature of the hot water that was already in the tank, and the shower would start to cool down noticeably during a shower because we were taking that nice 135 degree water that was up here and we're blending it with cold, slightly heated water from the bottom of the tank. It was effectively destroying the temperature in the top of the tank. Whether it was consuming any extra energy from the heat pump or not, I don't know. But if that was electric or gas, you would never notice it with the energy consumption because the temperature that you're delivering the heat doesn't matter with those fuels. With a heat pump, the colder we can get the water going into the heat pump, the more efficient the heat pump will be. So it's best to take the water right off the cold inlet to the tank. So we're getting the coldest possible water coming in. This is the cold water going in. All right, take the lid off here. So basically this is our pump inside of this box right here. It's insulated. The water comes in, it gets pumped into the heat exchanger, which is this box right here, insulated as well, and then it comes out through here across, and then it goes back to the bottom drain of the water heater tank. And then the compressor right here is what's responsible for providing us the pumping of the heat with refrigerant 290 vapor going in over there and liquid coming out the bottom through that copper line that you see tucked away back there. It comes through here. It goes through a capillary tube which begins here, expands, goes through the evaporator coil on the other side of the machine, and the fan that you see draws air from the room and across that evaporator coil and heats up the refrigerant and boils it back to a vapor. Vapor comes through here, gets compressed, and then it repeats the cycle back to the water heat exchanger, heats the water up. We got our temperature controller. I'm still monitoring the temperature at the bottom of the tank through a thermocouple. It goes in right here. It's just shoved up in behind the insulation. It seems to work all right. So that's it. That's the change. We got it up off the floor and away from the boiler, away from out of the way here. So now I'm able to utilize this little cubby hole back here in the corner, space that otherwise would go to waste. You can see it's got a rocky, dirty floor in back here. So this was able to make use of this location. Now, one thing that's interesting about this location is this is the drain line for the upstairs bathroom. So when I'm showering in the upstairs bathroom, the drain water is actually flowing in this pipe right here to the sewer. It goes to the sewer line down that way. So that bottom of that pipe is actually going to be heated by the drain water from the shower. What's kind of more theoretical than it is practical is the cold exhaust air from the evaporator coil actually can blow against this pipe and cool down the pipe, theoretically cooling off the water that's inside the pipe and heating up the air and recovering heat from the drain water. It's not going to work very well because it's a plastic cellular core pipe. So the thermal conductivity of the pipe isn't very good. But if that was a copper pipe, you could actually get some reasonable heat exchange, and you could build some cowlings that would go around this pipe and direct that cold 48 to 50 degree air across that pipe and cool off that water and blow that heated air back into the room, and then it's going to reclaim it when it gets sucked back into the heat pump. So it's more of an idea than anything, but it's obviously the infrastructure is here, but it's not something I'm going to do because it just really isn't that much energy. It would be a pain in the ass to try to build all that stuff. So that's it. That's the heat pump water heater update. This thing has basically been running for 3 months now. All hot water. There is no gas being used at all. It's actually shut off. So I even blocked off the exhaust. And that's why there's a label here in the event that it was ever necessary that somebody would know. The exhaust is blocked. You got to unblock the exhaust before you fire up the water heater. Just take that piece of insulation out of there. That's all it is. So that's it.